Leetcode 200, number of islands. It's a medium type problem, and I would say it's quite standard for medium. And here is the description. Given an n times n 2D binary grid called grid, and sometimes we have m times m or n times n grids, and then they are square, and it's an easier variant. But at this time, we have to take care of the situation where rows and columns are different. Yeah, so there's potentially different number of rows and columns. And here is what this grid represents: a map of ones and zeros. Yeah, and ones represent land and zeros represent water. Yeah, so we can expect that there will be just ones and zeros given as strings. Yeah, in Python, if you take a look at the right side, we have lists of strings. Yeah, and of course this outer list contains the inner rows, and each row is consists of strings, but those strings have certain constraints on top of them, meaning that each will have just single character, and those characters will be taken from a set or a pool of 2. Yeah, so there will be just binary, either 1 or 0. That's guaranteed. And we have to return the number of islands. And of course, ones represent land. And here is some additional explanation. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all 4 edges of the grid are surrounded by water. Yeah, so here is a certain example. The first one, as you can see, have a lot of ones, but all those ones are connected to each other, meaning that in total there is just a single island. Yeah, and here is a second example. We have 3 islands, and as you can see, the first one is here in the upper left corner. Maybe let's copy that to see it better here, since I cannot draw there. Where are those islands? So the first one, let's use green for island, is this one. Next one is this one. And the third one is this one. And because the connections are only up, down, left, and right. Yeah, we don't connect on the diagonal, which is important. Sometimes there are connections to diagonal. In this case, there are not. And this is very vital information for us, meaning that if we just connect through diagonal, we have to consider those islands separate. And we have to count. And we can use the following algorithm. So let's first try to write some high-level overview of what we can do. And the high level would be to iterate through each cell, of course. So you can already see that the time complexity will be at least m times n, yeah, not n squared, because we can have different number of rows and columns. But if n is bigger than m, then it will be n squared, or could be bound by the n squared. But let's first concentrate on this. So iterate through each cell, we basically can use 2 loops: an outer loop, which will go through the rows. Yeah, so in Python we could write something like for row in grid, and it will go through each row. And then we have to go through each column. Yeah, and having both row and column, we can get a single cell. Yeah, so the inner loop will be tracking the columns, and the outer loop will be tracking the rows. And even write this down. So outer and inner loop, and outer loop tracking rows, and inner loop like this tracking columns. So that's the first thing. And what are we looking for? We are looking for ones. Yeah, so let me just add a new one. If we encounter 1, yeah, then we have to increment some counter. So we have to count how many islands there are. meaning that we need some counter for it that we first initialize with 0, and then each time we find 1, we will increment it by 1, and the same time, and it will be like the next step here, unmark all connected 1. And that's it. So, don't like this. And that's like the inner point. So once we encounter 1, we can increase some counter increment by 1 and 1 by 1, and then just remove all the surrounding ones so that we don't overcount and we count single island once. Yeah, and how can we do this part? This is the most interesting part. We can use graph algorithms for that, either BFS or DFS. We can also use some other, but usually when there is like no explicit advantage or the problem is not extremely hard, as in this case it's just a medium, you have a free hand between DFS and BFS. Yeah, so we explained a couple times what are the differences, in which cases we use mostly, or in which cases BFS is more advantageous than DFS, what other algorithms there are. So I will not go into great detail. Just a short reminder that those are like graph traversal, meaning that we can we can go through each connected element called usually node or vertex in a graph using this algorithm. Next, have some starting point and then traverse, go through each node if there is a connection to that node, because of course there are also disjoint graphs. And BFS goes to each neighbor. I always misspell. Sorry. BFS goes to each neighbor and then continues to neighbors of the neighbors, right, in layered fashion. So first, we would in BFS we would visit all the neighbors, then next neighbors and next neighbors and so on. And DFS, for some reason, it's at least for me, is usually easier to think about and easier to write. It requires a little bit less code. That's why I usually prefer DFS over BFS. Goes along taken path as deep as possible, and then backtracks. One step behind, not to the very first step, but goes as deep as possible and backtracks one step, tries to go again as deep as possible, and so on. And backtracks one step when it reaches the end. Okay, that's it. And both have basically all of V plus E time complexity, where V is the number of vertices or nodes and E is the number of edges. And so when it comes to time complexity, generally they are all the same. And of course there are other differences, but let's not go into great detail. This time we are using DFS, and you will see it in practice. And if you're struggling with both of them, then you can go to some other videos where I explain them in more detail. Yeah, in this time we just go with practical approach and implement DFS. Why do we implement DFS? Because we can think of those grids, 2D matrices, as graphs. Yeah, so 2D matrices / grids are also graphs. Each cell is a node. and connections up, down, right, left are edges. Connections, let's double. Yeah, that's it. So we can use DFS for what? For once we find one, yeah, we can use DFS to find all surrounding ones and change them to zeros, and that would be it. Okay, so that's like short theoretical intro. Let's now try to implement. And of course, if grid is empty, then we return 0. Now we can create n and m. And no, here they are using this notation, m and n. Yeah, so I think it's sometimes it's swap. I'm not sure. I'm also mixing it up. But basically, once you decided which size is m and which is n, then you should be consistent within the given program or given problem. Yeah, so for this particular case, we call m the length of the grid, meaning the number of rows, and we call n the length of the row, meaning number of columns. And we create some counter, which we initialize to 0. Now let's use our DFS to unmark all the surrounding ones. And if we go out of bounds, yeah, so if I less than 0, j less than 0, or I greater or equal to m, or j greater or equal to n, or we already reached the ocean, meaning the grid of I and j is equal to 0, and then we return. Otherwise, let's do it like this. Otherwise, what do we want to do? Let's first make sure that the tabs are taken care of, and otherwise we want to unmark, meaning that we want to set it to 0. Yeah, and then we want to call the DFS on our neighbors, and basically we can have at most 4 neighbors. So let's call like this. I plus 1. So I minus 1. So basically top, bottom, right, and left. Yeah, minus 1, plus 1. Doesn't matter in which order. Either way, we want to visit all of them. And now we want to do for I in range m, and for j in range n. I hope that I'm not mixing it up. If we have found an island, then we increase our counter by 1, and we call DFS. That's it, to unmark all the surrounding land, and then we return the counter. And that's it. Let's try to run and see how good was my indentation. Of course, line 14. I hate this Leetcode editor since not really that visible and it doesn't mark the errors. Geared. I misspelled grid. Where is this geared? Here. Already in the first time I tried to use it, I already misspelled it. Yeah, and that's also why I don't like it, because you have to wait till you run to see like syntax errors and stuff like this. Okay, so first 2 cases work. Let's see on all the cases how it goes, how we do, and we beat 86%. of other competitors when it comes to time, and 68 when it comes to memory. And that's it.